Hi everyone in Algebra 2B. Today we're going to be going over your questions on lesson 106B. To start, we're going to do number 16. So we're going to solve for the bottom equation for y. If I move the y to the right and the 2 to the left, I get y is equal to 2x minus 2. And then I'm going to substitute that into the top equation. So that would become x squared plus 2x minus 2 squared equals 7. I do need to multiply that out, so that would give me x squared plus 2x minus 2 times 2x minus 2 equals 7, and you have to fully multiply that out. So 2x times 2x is going to give us 4x squared. Then I have 2 times negative 2 would be negative 4x. Negative 2 times 2 would be negative 4x. Then negative 2 times negative 2 would be positive 4. We also want to bring the 7 over to the left-hand side, which would be minus 7. Now when we simplify this, I have 4x squared plus x squared would be 5x squared. Negative 4x minus 4x would be negative 8x. And then 4 minus 7 would be negative 3. That's going to be set equal to 0. Now to solve, we're going to do quadratic formula. So x is going to be equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. And I don't have a ton of space here, so I have positive 8 over 10 plus or minus, so 8 squared is 64 plus 4 times 5 times 3, which would be 124. The square root of 124, so I could divide that by 2, divided by 2 would be 2 square root 31 over 10, meaning that my result for x is going to be equal to 4 over 5 plus or minus the square root of 31 over 5. So I kind of had to skip a few steps in there to try and make sure it fit. Then I have to solve for y. So that would be 2 times what I got here, so 4 over 5 plus or minus the square root of 31 over 5 minus 2. So if I distribute that, I get 8 over 5 plus or minus 2 root 31 over 5 minus 2. And I want to combine this 8 over 5 and the negative 2. So I need a common denominator of 5. So 8 minus 10 would be negative 2 over 5 plus or minus 2 root 31 over 5. And that would be what y is equal to. So we did substitution on this one and then had to use quadratic formula. But you just need to make sure you're very careful with where you put everything, all your pluses and minuses, and make sure you're just very careful with that. So for number 17, you were supposed to do substitution for this one. So what I'm going to do is I'm going to solve this bottom equation for x. So that would give me 2x is equal to positive 5y plus 26. Then I'm going to divide that whole thing by 2. So I would get x is equal to 5 over 2y plus 13. Now what I'm going to do is I'm going to substitute that into the top equation. So that would be 5 times 5 over 2y plus 13 minus 3y equals 27. Now after distribution of the 5, you would get 25 over 2y plus 13 times 5, which is 65, minus 3y equals 27. I'm going to bring the 65 to the other side, and then I'm going to make a common denominator. So I have 25 minus 6. So that would be 19 over 2y equals 27 minus 65, which is negative 38. And that would be over 1. So to get y by itself, you're going to multiply both sides by the reciprocal of 2 over 19. And luckily, 19 does go into 38. Goes in 2 times. Which means that y is going to be equal to negative 4. Now to solve for x, all you have to do is plug that into this equation here. So I have x is equal to 5 over 2 times negative 4 plus 13. 2 goes into 4 2 times. Don't forget the negative sign though. So you have negative 10 plus 13. So x is equal to 3. So because you had to use substitution, it did get a little ugly there for a second. But then after solving, you ended up with 2 whole numbers as your answer. For number 18, the first thing that I am going to do is going to be to solve for y in this equation. So when I bring the x to the other side, it's going to become negative 3x plus 8. I have to divide by negative 4, but remember that when you divide by a negative number, it flips your inequality. So this is going to become y is less than or equal to 3 over 4x minus 2. Now this is going to be a solid line, and because it's less than, you're now going to shade below. Then for greater than, it's going to be a dotted line, but you're going to shade above. So for the first one, negative 2 would be here on the y-axis, but you're going to have a dotted line through it. And for the second one, it's also going to cross at negative 2, but the slope is going to be up 1, 2, 3 over 1, 2, 3, 4. And this one's going to be a solid line. And it should look something like this. So if I'm going to shade, I'm going to start by shading everything below the solid line. So if I shade everything below the solid line, it would look like this. Shade everything below it. Then if I want to shade everything above the dotted line, that would be everything up here. Everything above. So your answer is going to be the portion that's shaded by both, which means it would be the portion that's under this solid line but above the dotted line. Now moving on to number 19. So for number 19, I'm going to start by just simplifying. So I squared is equal to negative 1, and then I cubed is equal to negative I. So really what I have here is 3 plus 2 minus I over minus 3I plus 3I plus 2. Which means that the 3i's actually cancel. So really you're left with 5 minus I over 2. Now for number 20, solve by completing the square. I need to start by moving the 7 to the other side. And then I have to divide anything that's attached to the x squared. So I get x squared minus 1/3 x equals 7/3. Now the term that's attached to x, the negative 1/3, you have to multiply by 1/2. and that's going to give you -1/6. So that means I would end up with x minus 1/6 squared. I have to square that now, and that would give me 1/36, and that's what I'm going to add to both sides. The common denominator is going to be 36, so I need to multiply top and bottom by 12. So 12 times 7 is going to give me 84, plus 1 would give me 85. And then I need to take the square root of both sides, remembering that I need to put the plus or minus in front of the square root. There is no square root of 85. It does not simplify, but the square root of 36 would be 6. And your final answer would be you moving the 1/6 to the other side, making it positive 1/6 plus or minus the square root of 85 over 6. Now looking at number 21, I'm going to start by making my triangle. So I'm going to start with my triangle in quadrant 1. Goes to the right of the origin, so it's positive, then comes up off the x-axis, making the u positive as well. And then the second triangle, the r would be negative because it comes to the left of the origin and it comes down, so my u would be negative. Now when I solve for x, I'm going to have slant times cosine of your angle. And for y or u, you're going to have 12 times sine of your angle. I'm going to do that for both, so that would be 10 times cosine of 70, and then y would be 10 times sine of 70. So I'm just going to evaluate using my calculator. So 12 times 15 cosine equals, that would be 11.59. Then 12 times 15 sine equals, that would be 3.11. Then 10 times 70 cosine equals, that would be 3.42. And then 10 times 70 sine equals would be 9.40. So for my first one, my x is positive and my y is positive. So that means I have positive 11.59r plus 3.11u. My second one, I have negative and negative, so that's going to be negative 3.42r and then minus 9.40u. You're going to use your calculator again. So that would be 11.59 minus 3.42 gives us 8.17r. Then 3.11 minus 9.4 would give me negative 6.29u. And that would be your result. Now for number 22, this actually looks very similar to the one that you had on your test. So what I'm going to check first is if all of my x's are different. If they're all different, then I know it's a function. So I have 4, negative 3, 8, 4. Okay, wait, I have two 4s. But look, they both actually lead to the same x. So I can actually just cross one of them out because as long as it leads to the exact same y, then it's fine. I have 8 goes to 5, 3, negative 2. But then I have 8 goes to 5 again, but both of these 8s go to 5, so I'm going to cross that one out. Then I have 11 to negative 3. Now that I've crossed these out, I have 4, negative 3, 8, 3, and 11. All of those x's are different, and it doesn't matter where they lead to, which means that this is a function. So if it's the exact same xy combo, it's fine, and it is considered a function. Now number 23, I have this whatever pitchfork theta of 1/2. So we have to multiply this times theta of 1/2. So my pitchfork is going to be x plus 2, and my theta equation is x squared. So if I multiply these two, I get x cubed plus 2x squared. But then I have to plug in 1/2. Remember that this value has to be in the domain of the other two functions. Is 1/2 a real number? Well, yes, it is. But is 1/2 an integer? It's actually not an integer. So because of that, you can't actually plug this in, and your answer is either going to be your null set or the empty set. You can't actually solve the answer because 1/2 is not in the domains of the two functions. Now looking at number 24, this is a pretty recent lesson. So I'm going to start by putting my m minus p on the outside. And then on the inside, I'm going to put my m cubed, then my 0m squared, my 0m, and then minus p cubed. So division works the same as it was before. So I'm going to first divide m cubed by m, which gives me m squared. When I multiply this, it's going to come out as m cubed. M cubed times negative p would be negative pm squared. Because I'm subtracting, though, the positive turns to a negative and my negative changes to a positive, I cancel out my m cubes. I'm left with just pm squared, and I can carry down my 0m. Now, when I divide this by m, I'm just going to get positive pm. When I multiply pm times m, I get pm squared. And when I multiply pm times negative p, I get negative p squared m. Now I have to change both of my signs. So this becomes negative, this becomes positive, and my pm squareds cancel. Now I have p squared m and then minus p cubed. Divide my term by m, that cancels out the m, so I really just have p squared. Multiply that would be p squared m. Multiply the p squared times negative p would be negative p cubed. Again, you're changing the sign, so that becomes negative, this becomes positive. Not only is your p squared m canceling, but your p cubed also cancels, leaving you with an answer of m squared plus pm plus p squared. The next ones are going to be all about factoring, and we actually learned this in lesson 105, and there's 5 steps that we have to follow. So I'm going to take those steps out so that you're able to hopefully follow along with those steps. There's 5 of them, so it is a pretty long problem, so make sure that you're following along. So what you're going to do first is it has to be set equal to 0. And then you're going to start by multiplying the first times the last term. So in this first one, I have 3 times 2, which is going to give us 6. Now what I need to do is find the factors of this number that add up to the middle term. So I need my factors to add up to 7. So for number 2, well, I'd have 2 times 3, but that would add up to 5, so that doesn't work. The only other one I would have would be 1 times 6, which would add up to 7. So the 1 and the 6 is what's going to replace my middle term. So these are your 2 middle terms. So for step 3, it would be 3x squared. Instead of 7x, it's going to be plus 1x, and then plus 6x plus 2 equals 0. So that becomes your middle terms. You're going to factor your expression. So I'm going to put the first 2 terms in parentheses and my second 2 terms in parentheses, and see if there's anything I can factor. Well, in both of these terms, there's an x that I could factor out, which would make that 3x plus 1. In my second parentheses, I can factor out a 2, which would make that 3x plus 1. So now for step 5, you factor out the like expression. Factor out the like expression, which would be the 3x plus 1. So for step 5, you would have 3x plus 1 times what's left, which would be the x plus 2. But because you're solving, you factor that into 2 parentheses, so now you have to set each of these equal to 0. So I'm going to set 3x plus 1 equal to 0, and then x plus 2 equal to 0, because you're solving for x. So for the first one, when you move the 1, it becomes -1. So you have 3x is equal to -1, which means that your first answer is going to be -1/3. For your second answer, when you move the 2 to the other side, you get -2. Your result is x is equal to -1/3 and -2. Now looking at number 26, we're going to follow the same exact steps. So these 5 steps here. I hope you guys had those written out because that would be very helpful. So the first thing is to multiply the first and the last term, so 3 and 2. Which gives us 6. And for this one, well, I have to find the multiples that would add up to +1. And I need to make sure that I wrote this down correctly. So this is so this should be a -2, my bad. So these number that they would need to be able to add up to +1. So that would be 3 and -2 would add up to +1. So 3 and -2 would add up to +1. So that means that these are now going to replace my x. So step 3 is these are your 2 middle terms. So I have my first term, which is 3x squared. Instead of 1x, I'm going to have 3x and then -2x, then -2 equals 0. You're going to separate these into 2 different expressions. So it's going to be 3x squared plus 3x in your first parentheses. Second parentheses is going to be -2x minus 2 equals 0. So what can I factor out of the first term? Well, in the first term, I can factor out a 3 and an x, leaving me with x in the first term and 1 in the second term. The second parenthesis, I can factor out a -2, which would leave me with x and +1 in the second parenthesis. You're going to factor out the like expression, which means that you're going to have x plus 1 times 3x minus 2. And to solve for x, you're going to set each of these equal to 0. So you're going to have x plus 1 equals 0, and then 3x minus 2 equals 0. Move the 2. So you have 3x equals 2. So your answer is going to be x is equal to 2/3, and then x is equal to -1. And those are your answers. Now, I'm not going to use a piece of paper because it's going to get too long if I just look at it, but hopefully you have them right next to you. So I'm going to still follow the steps. So step number 1 is to multiply the first and the last term. So that would be 2 times 15, which gives me 30. that I'm going to now try to find the multiples of 30 that add up to 13. So you could do 6 times 5, but that adds up to 11. You could also do 3 times 10, which would add up to 13. So that's perfect. So 3 times 10. 3 and 10 are going to be your two middle expressions now. So instead of writing 13x, or 13z, you're going to have 2z squared plus 3z plus 10z plus 15 equals 0. Now you're going to separate the two expressions into two expressions. So I'm going to put the 2z squared plus 3z in one, and then the 10z plus 15 in the other. What factors out of the first parentheses would just be a z, and you'd be left with 2z plus 3. Second term, I could factor out a 5, which leaves you with 2z plus 3 as well. Because you're solving, so for step 5, I'm going to factor out the common term, which would be 2z plus 3, times what's left, which would be z plus 5. And now you're going to solve for z. So you have to set each of these equal to 0. So 2z plus 3, and then z plus 5. Now I'm going to start by moving the 3 to the other side. So I have 2z equals negative 3. Divide both sides by 2. And that would give me z is equal to negative 3 over 2. And z is equal to negative 5 because of that second expression. So those are the 5 steps. We're going to go through them like 3 more times. But for this one, what I need to recognize is that there's actually something I could factor out of all 3 of these terms. All 3 of these terms are divisible by p, but they're also divisible by 3. So if I factored out a 3 and a p from the beginning, I would be left with, in the first term, I would have 2p squared. Second term, I would have 11p. And last term, I would have 15 equals 0. So now I'm going to follow my steps. So my first step is to multiply the first term times the last. So that would be 2 times 15, which gives me 30. I need the multiples of this number to add up to 11. And if I look at the last one, I needed to find the same thing. And I knew that 6 times 5 actually adds up to 11. So now the 6 and the 5, I'll replace my 11p. So for step number 3, I have 3p on the outside. But then I'm going to have 2p squared plus 6p plus 5p plus 15 equals 0. I'm going to separate those into 2 separate expressions for step number 4, leaving the 3p on the outside. I'm going to have 2p squared plus 6p in one, and then 5p plus 15 in the other. And I can factor out of both of those terms. So in the first term, I can factor out a 2 and a p, which would leave me with p and 3 in the second term. Second term, I can only factor out a 5, but that would leave me with p and a 3. So now what I'm going to do is I have 3p on the outside. I can factor out the p plus 3. And when I do that, I would be left with the 2p plus 5. So for this one, I have to solve for p, but I have to solve 3 equations. So I'm going to set 3p equals 0. I'm going to set p plus 3 equals 0. And I'm going to set 2 2p plus 5 equals 0. Moving the 5 to the other side makes it negative 5. So you get 2p equals negative 5. So my result for the first one would just be p is equal to 0. My result for the second one would be negative 3. And my result for the final one is going to be negative 5 over 2. So that one you should have. For 29, I'm going to start the same process. So step 1, I'm going to multiply the first and the last number. 3 times negative 10 would be negative 30. And now I need to find the multiples that add up to negative 13. So I could do 3 times negative 10 would be negative 7. Well, that wouldn't work. 5 times negative 6 would be negative 1, so that doesn't work. But what about if we did 15, negative 15 times 2? That actually adds up to negative 13. So these are going to be your two middle terms. So that would be 3p squared minus 15 plus, or 15p, and then plus 2p, and then minus 10 equals 0. You're going to separate these into two expressions. So 3p squared minus 15p plus 2p minus 10 equals 0. In the first expression, I can factor out a 3 and a p, leaving me with just a p in the first term and then minus 5 in the second term. Second parentheses, I can only factor out a 2, so that would be p in the first term and then minus 5 in the second term. Now what I'm going to do is I'm going to take out the p minus 5. And if I take out the p minus 5, I would be left with 3p plus 2. Now to solve, you set each of those equal to 0. So p minus 5 equals 0, and then 3p plus 2 equals 0. You're going to move the 2 to the other side, making it negative 2, so 3p equals negative 2. My two answers are going to be p is equal to 5 for the first one, and then negative 2 over 3 for the second one. And lastly, we're going to look at number 30. So for number 30, we are going to start by moving the a squared over to the left-hand side because it has to be set equal to 0 before I can do this. So it would be 2a squared minus 11a plus 15 equals 0. You're going to multiply the first and the last term. So I have 2 times 15, which is going to give us 30. Now, what two numbers multiply to give us 30, but add up to give us negative 11? So add up to give us negative 11. That would actually be negative 6 and negative 5. They multiply to give us 30, but they add up to give us negative 11. This is going to be our two terms. So I have 2a squared instead of negative 11a, I have negative 6a. Negative 5a, and then plus 15. You're going to separate those into two separate expressions. So I have 2a squared minus 6a in my first, and then negative 5a plus 15 in my second. Now what can I factor out of here? I can actually factor out a 2 and an a, leaving me with just an a in the first term and then a minus 3 in my second. Second one, I'm actually going to factor out a negative 5. So I'm left with a in the first expression and then negative 3 in the second. You should see that for step 5, I can actually take out an a minus 3. And when I take that out, I would be left with 2a minus 5. To solve for a, you're going to set each of them equal to 0. So you're going to set a minus 3 equals 0, and then 2a minus 5 equals 0. So I'm going to move the 5 to the other side, giving me 2a equals 5, meaning I have two answers. A is going to be equal to 3 for the first one, and then A is equal to 5 over 2 for the second one. And that should conclude all of your questions on lesson 106B. I hope you guys all have a great day. Bye.